Hello everyone. So I would like to start with a small question. Who is absolutely doesn't have any Puppet code yet? So who's starting from scratch? Okay, so yeah, you can take the best practices from this because you won't be breaking much since there's nothing to break yet. Lucky you. I'm assuming that the rest already has like a set of code to work with. So that's what I'm going to be chatting about. I'm going to do a really small skit about myself. I've been freelancing for 8 years, from which I've been running on a mix of espresso, sarcasm, and whiskey. This seems to be like a default combination in the field. And the last 6 years, I've been trying to get machines to do the same thing with Puppet. And most of the time, they actually did what I asked them to. I did this at large companies. I had the pleasure of working at TomTom, eBay, Kobo, currently at Sanoma, where we're trying to build a bigger team because there's lots of work we still want to get done. So to get to a quick overview on what I'm going to be chatting about, making changes is hard, and it's hard for multiple reasons. So I've split this up in like a grand overview. I will not be going in depth too much, mainly because there isn't enough time. I could fill an afternoon on that. So we'll start with the basics, and that's mostly how to get started, what things to watch out for, but also how to get the time to make changes, because improving Puppet code is a zero-sum game for the business, because it's running now, right? So why are you spending all this time working on the Puppet code? They don't immediately see the benefits of improving it. So that's the basics. It's mainly about prepping yourself for making the changes. Then I'll be chatting about code strength, which will be mainly about how you can make sure that your code doesn't break when you're working with it, how you can make changes without it affecting your current situation. Then we'll talk a bit about deployment, because when you're thinking about writing code, it has zero effect until it's running in production, because that's the end goal for it. And just like in real life, the last thing we'll be talking about is documentation, because nobody really likes writing it. At least I don't know many people that do, but sometimes it's necessary and sometimes it's not, and I'll be discussing both views on that. I'll have a final slide in this presentation, which you will not be seeing, or I'll be skipping over it, which has links in it. So if you open the presentation later, you don't have to write down all the long links or make notes on it. So yeah, this is a bit what happens very often. You get a Puppet code base, and there's a lot of stuff in there, and some things don't make sense immediately, others do make sense. Things are written from an old perspective, and you want to work with this longer, so always trying to find your way is going to be a bit hard. So you want to improve at some point, because in a perfect world you would have gotten code which was written to the latest knowledge and standards, but Puppet code tends to grow, which is a bit the idea. I mean, new machines come in, old machines leave, things stays lingering around, you find passwords in your code base. So why do you want to improve your Puppet code? Well, in practice, you try to avoid one of the three possible scenarios. One is that at some point somebody's going to tell, like, okay, you know, it's too messy, we can't get this fixed, let's start over again, and then start working a lot of time to get the same mess you had before, because history tends to repeat itself. Another one, which is even worse, is that people lose trust in Puppet or in the code base, because making changes breaks stuff, and people start working around it, so you get like shell scripts running again, and then we're basically back to the dark ages, where we don't really know what our server is doing. And then the final one is, you know, I think it's Puppet, let's change to another tool, which is the same as starting from scratch. You'll just re-implement the same mess in a different tool. These are basically the things you try to avoid, because you're doing a lot of work and you'll end up back at square one. So the first bit is partially management. So this is why I took this picture, because you want to get time to do this, and that part is tricky. You can't solve everything just by running extra hours and writing code. At some point you need your company to be behind the changes, because other people need to work with your stuff, and you need to get the time to do it and not constantly get taken away from your job doing small stuff, because what you're doing, you know, is working anyway, so don't take the time for it. Because there's like this hidden cost in constantly tacking on small stuff, and if you do not get that early on, slowly but surely you'll be spending more and more time fixing old stuff and less time implementing new features. So one of the things I learned is that the first thing you need to do is be there. I had the pleasure of working remotely for a while, and this is very nice, but you never get the feedback you need, because you need to know what people actually need so you can get the big rocks out first. And you need to talk with the people that need to work. Other people need to work with your code, use your code, or also help you code. If you're not there and you can't listen to them, then very often they'll start working around you, because basically you didn't write the documentation yet, you didn't have time for that. But also, even if you have documentation, they don't know where to find it, and they also don't know the grand vision that's behind it. And this is the most important one, at least my lesson is, unless you have nothing yet, don't start from scratch. Because there's a lot of stuff you already fixed in history. Other people already fixed stuff. If you try writing from scratch, very often you will end up with two code bases. For example, sometimes if you start from scratch and you say, like, we'll start a fresh Puppet master with a new Puppet manifest on it, then in the end you're managing two platforms. You're managing the old one and you're managing the new one, and people that are working on the old one don't have time to migrate to the new one, so they'll just add patches to the old one, and basically you're doing double work. You're much better off figuring out a way to transform what you have slowly into a new system. The biggest benefit you'll have is that people will see the improvements. There will be gradual, there will be a communication line starting at some point, because I've always been doing it like this. Why use that one? Well, this one's a profile with one line, and the other one you still have to manually set up half of the files, for example, or monitoring. So this is, if there's one thing you take away from it, try to avoid writing from scratch unless you have a very, very good reason. If you don't think you have a good reason, my email is in the end. Send me an email and I'll tell you why it's still not a good idea. The other one is that you need to have some kind of plan, because if you don't know where to start, it's a big project on itself. You don't have to make like this huge Gantt chart thing that some people tend to use. I prefer using something from Getting Things Done. Is there anybody who's used Getting Things Done? There's a few people. And for those people who don't know Getting Things Done, he has a 5-step, I added a few, process for project planning. You don't have to think this big, but one of the things I find very important is the first question, why? Why are you doing it? Why are you improving your Puppet code? If you can't answer the question why you are doing this, how is your boss going to explain that when he has to sign off all your hours working on it? It doesn't have to be hard. It's very often, we're improving this because it's costing too much time, and if we don't do it now, at some point we won't be able to add new features. But try to summarize that. And then the second is when, and that's when are you done? When is this improvement done? When can you start working on new features? Because that's also an important question, because you want to know, when are we successful? What's the moment that you can go out and get a beer and say, good job? The what? This is, to me, usually the fun part is when you get together with a couple of colleagues and everybody just starts shouting. We need this, we need that. Don't think about what order you need or if you absolutely need this. Just write it down somewhere. Make a list, just write down, we need this roles and profiles thing everybody's been talking about. We need spec testing. It's all one-lines, and you can just scratch them away later on when you decide you don't need it, but the important thing is that you don't forget, because that's where it usually ends wrong. You don't write down anything, you try improving it, and at some point something gets forgotten, and then something breaks, and somebody says, see, it's not helping. After you've written down, somebody has to make a plan. Basically, the machine goes through the list and just pick 3 things that you want to start doing on first. I wouldn't recommend spending weeks making a grand plan. But find out what do we want to change first. I'll be chatting about that in this presentation. And the final step is do. And at some point somebody has to get coffee and make the code. I prefer doing stuff in Agile. I don't think people should immediately say, we'll start with a whole Scrum setup, but the important thing here to take away is get it visual. Make sure that when you're working on this Puppet code and nobody sees it, that they at least can see on some kind of board, list, whatever, something you throw in their face. I don't care if it's like a book you throw at them. Anything that shows them that you're busy, that you're actually doing work, because else people will start taking away from your time. You will not be making improvements. You're ending back at square one. Yeah, I prefer using Scrum, but that's because I like planning a lot. So that's the advice I have. I'm a bit weird on that way. Other people like using Kanban. I think that the main thing you should just really take away from it is get it visual. Make sure that you can show people by a list of stuff you need to do that you're busy. Get them off your back while you're making this upgrade. Also, yeah, the subtext on how to trap management. The reason why I'm saying that is that it's very useful that when you're in the start of the project and you have plenty of time, that's the point where you say stuff like we need testing and we need documentation. Because you won't get testing and documentation when the feature needs to be released. That's the point where somebody's going to say, oh, well, let's drop the testing, it takes too much time. Let's drop the documentation, we can do it later. If you can't do it now, you won't have time to do it later. I can guarantee it. So talk to the people who are signing off your hours and say you need this. It's better to have like less work done after the first month, but have it done right so you can let it go, than having a lot done and an even larger list of things you still need to do for which they will toss it away at some point. So code strength. Code strength mainly means that you can make changes, and then when you make those changes, that you are confident that you can put it in production. So this is, the term spaghetti code comes to mind. When you have the feeling that when you're pushing a button somewhere in your Puppet code and you're not sure if something will break on the other end of the spectrum, that's when you need code strength. That's when you need to take time to look at your code base and see what can I do to make it stronger, to train it basically. So good Puppet code is easy to change and hard to break. Well, not that much harder to break, but at least it's hard to break in production because in the meantime you will catch your errors. So the first step there, peer review. If you're in the position that there's no one you can peer review it with, it's a bit tougher, but usually you have a team or somebody else who does Puppet code, and looking at each other's code has a lot of benefits because you learn things, or you learn that other people already written something and you're redoing the same work. It's also a nice way to have a good chat on what solution is best, and it saves you a lot over time. In the beginning it will cost you some time, but over time you will learn stuff from each other. Definitely when you're beginning with Puppet, your team is learning and you want to get that knowledge. And the best way to get it is to look at each other's code, because you'll see other people do smart stuff and other people will see you do stuff and say like, I know there's a smarter way for that. This helps you. One of my favorite tools for it, I don't get to use it at the moment, but at other companies is Gerrit. If anybody ever used Gerrit, heard about it? Great. So yeah, it's a tool. It doesn't look very nice, but it's very, very functional. It's written to be functional. It's something you start to appreciate when you have to work with it. Then another thing, and I already mentioned that a few times, is spec testing. So who does spec testing? Because I really would like to know. That's not much. Yeah. Okay, so spec testing. That's one of those things that if you ask most people, then the answer you'll get, I hope you like writing it twice, because that's what you're going to do, right? You're going to write the same code twice. And I would like to change that perception. I want to make that into the operations way of thinking it. It's high availability for your code. It's the second set that's next to it, so that when you make a mistake, somewhere a machine will catch it and say like, you made a change here, are you absolutely sure? It's a bit the yes-no dialogue of Windows, but then a functional one. So start writing a few of this code, because it isn't that hard. It takes like maybe a few hours the first time to get your first test set up, but it isn't difficult to look at. This is an example spec test. This is basically my Vim template, which I use. There's a small bit added to it, and that's this one, the OS specs, because very often I need to load the parameters for a Linux or a Windows machine because I want to see if my module works against it. But it isn't hard to read. It's probably a bit harder to write, but after you've done it a few times, it becomes second nature. As you can see on the top, there's a require. Spec helpers from Puppet Labs that helps you test Puppet code. So yeah, you basically are required to use that unless you want to do a lot of manual stuff. The OS specs is from me, so it's basically two variables that get loaded in. You can use it. And what I do is I make a describe which says that I want to test my profile test module. It's a class, and by default we always test by default without settings because I want to see if the module works or if fails as intended when somebody just uses the defaults, and do a few basic tests. So the real basic test I'm doing here is just saying, like, does it contain class test? You can replace test by Nginx, Apache, MySQL. Just this already helps because you have like a basically it started from. Start adding stuff to that. This looks very like a duplicate work thing, but in practice, once you start making changes to code later on, you can A, find stuff before it breaks, and B, when something does break, you learn something in practice instead of having to remind that every time you're writing code, put it in a test, forget about it, because it will fail when this same mistake happens again. There's nothing worse than explaining to someone that you broke the production environment for the second time when you knew what the fix was. I don't think anybody would be happy to start explaining that. Well, this one you guys already seen. Ger already did a good job on that one, so I'm going to skim over it and not go in depth as much. This will decrease my presentation a bit, but for those that basically missed the first part or like a short refresher, it basically means that you have roles, which is what type of machine. So I put an example here, like a WordPress standalone machine. And you get profiles, which are the elements you built the machine with. When I'm talking about profiles, I make a profile for every piece of software because I want to tweak stuff. I want to be able to make changes to my shared modules without actually changing the module. So I'm going to go in depth to the profile WordPress here. Oh no, Nginx. So what my profile Nginx does, it gathers my hero data. It gathers any external node classifier data and combines that to commands it sends through the shared module. But I can also add stuff to the profile thing. So I can add stuff like, okay, if I'm setting up vhosts for my Nginx, then I also want Nagios to monitor those vhosts. So instead of having to think about it when I'm writing my hero stuff, automatically I'll get monitoring because I thought of it once, written it once, and then reuse many. Another thing to do is write in small blocks. Developers call it dry. Yeah? Don't repeat yourself. By writing in small blocks, you get to reuse code very often. And reusing code is nice because it saves you time and gives you more time to either figure out more complex solutions or have coffee, whichever one you need most. And when you do start getting into bigger blocks, so when you're writing like a small block and it's growing, then either find a way to split it up or put it in a module as smaller components. And if you do put it in a module, then my advice is to think as if you could deploy it to GitHub today. If somebody would say like deploy it to GitHub right now, you say no, there might be some company stuff in there or something which is very specific, then you're not writing it generic enough. So unless you're in profiles, the profiles module, I would always recommend try writing it as if you would deploy it to public tomorrow. Excluding the part where you think that your code looks terrible and you don't want to show it to the world. Because, I always was very unsure about that until one friend said, forget it. Just send them a pull request if they don't like it, what's going to happen? In practice, people just don't answer. That's about the worst. Unless you're sending it to Linus. Because, yeah. Another thing I do very often is that when you get to a code base, you usually have two modules in there. You have the homegrown modules, and you have modules that come from the Puppet Forge. And that starts out very hard, because you don't know which modules are from you, which modules are from the Puppet Forge, and the worst ones, which ones are from the Puppet Forge and somebody made local changes. Because you won't know until stuff breaks. That's just too bad. So what I usually do to work around that, to slowly improve code, is I make a shared modules directory. You can chain those in the Puppet configuration, and I put that second. That means that I can check if a module is actually equal to the Puppet Forge module and move it to shared, and then start using that one, and okay, that part of my code base is clean, and then slowly but surely get to a point where my current code base only has the modules in that are specifically in-company written, and preferably, at least in my case, only contain rules and profiles. This is the reason why I'm putting the shared modules after, is because Puppet can't handle modules with the same name. So if you have an in-written module called Apache, and somebody gets one from the Puppet Forge called Apache because they think, okay, this one will work better, then by design it will load the in-house written one. And why would you like that one to be preferred? Because the in-house written one is tested and in use. If you suddenly replace that one with the external one, stuff will break, and this whole presentation is about not breaking it that often. What will happen in this case is that the person that loads the Apache module in shared will notice that his code will be broken and has to make a choice. He either has to spend the time trying to rewrite the Apache module in a new name or move it away, or not use the shared module, whichever is, well, he can apply, can use. So it's a bit tricky there. The worst thing you can have is that he actually throws away the share module. In that case, I recommend getting a stick out or something and explaining to him that changing code without checking with the rest isn't the best way to go. So after checking your code, testing it, having it designed, you need to get it somewhere. You have to deploy your code, because if it's not in production, it's not really done yet. Nobody's using it. So you're basically writing it for your own benefit. Maybe to read, you know, with a good glass of whiskey in the evening, but it's not something you can actually do. In my opinion, deploying code should only require two buttons. One is deploy to production, and the second one is coffee black. If you have more buttons, you have work to do. So I'm going to chat about which pieces are going into that. First of all, you want to auto-build. You've written those spec tests. You know which modules you have. You shouldn't think about how does this fit together. Basically, when you commit your code, you want it to auto-check out the code, put all the pieces together, run the tests through it, and then either tell you good job and we go on to the next stage of deployment, or bad job, this is broken, spend some time fixing it so that we can actually get this in production. Tools to be used for this are like Jenkins or Bamboo. They automate the process, they check your commit stream, and the things you want to test are, is the syntax correct? You can check that both for Puppet and for Jira. Is the spec tests all running well? In the beginning that won't be that much, but it will grow over time. And of course, I'm missing the one important, so, yep, spec tests, lint. Oh yeah, the one thing, it's optional but it's very important in my opinion, is I run Puppet lint over it. So I check if it has the same syntax. This has the benefit that the code will look the same no matter where you're looking at, and it makes it easier to skim through code because you expect things in the right place. Unless you're the only one writing code, then, you know, pick your own. But don't start complaining when somebody comes in and needs 5 days to learn how to write code your way. So yeah, the testing should be fully automatic. And you test against a snapshot. So when you combine all these pieces, you combine your modules, you combine your shared stuff, you combine your Jira configuration. This combination of software should have like a number, and it will either build or fail. I don't really care that much at this point because I will only deploy it when it actually builds. But by having this, you know, okay, I'm going to deploy this set, and if I want to roll back later on, I know that I'll roll back to this exact same subset. So this also includes your shared modules. There's nothing worse than stuff breaking because one shared module is like a .5 version higher than the rest. And you will be searching for like a needle in a haystack then. And this is then the last thing. Fully auto deployment very often is not desired, but what I do is that when everything's green, try and deploy it to like a test environment. Something with a few machines that are talking to it so that you can see if it breaks. I call this the canary approach. Does anybody heard about the canary in the coal mine? Yeah, so this is the same idea. You have a few machines that are on the risk. They'll probably break. In effect, because the way Puppet works, you should be able to do this. Because Puppet always, you know, has a different deployment schedule. Some machines will get their code sooner, others get later. So by design, if you have one machine that gets the Puppet code a bit earlier, it should just work. If it doesn't, then you already have like a problem because you know that when you're going to deploy it to production, it's going to end up at the machine eventually. If it needs to be on all the machines at the same time, it becomes a whole different type of deployment. In the end, once these machines are good, you need some way to check if it's going right. I highly recommend getting a dashboard for it. So if you're in the open source side, we're using Foreman on the moment. If you're lucky enough to have the Puppet Enterprise running, then you can use the Puppet Enterprise console. If you accidentally break something, you'll know quickly enough looking at these screens, because when all the machines suddenly start returning errors or keep making changes, run after run, then you know, okay, there's something wrong, and you need to dig down and find out why isn't this returning back like I'm not making any changes anymore, or why am I getting this error? Fix the error, get back to start, do a whole testing street again. That's why you want it automated, right? Because you don't mind going back, because you don't have to do everything. And then give it a second run. Also, be prepared to roll back. Have a same button for deployment as for rollback. It can be a bit more complex. You can basically say like a button with a specified version number. It's not that bad. Because usually with the way Puppet works, it doesn't matter. It doesn't have to be on the second, but you have a few minutes to figure out what the last version was and roll that. But have a button, at least. So the last bit, and it always gets last for some reason, is documentation. And most of the time, you actually get the 404 page. Because how many people here write documentation? That's nice. Do you all like writing documentation? Less hands. Yeah. So, do I need documentation? In my opinion, I shout this high and low whenever people ask you. There's two reasons for me to write documentation. The first reason writing documentation for me is I'm not going to be using this for such a long time that by the time that I need to touch it again, I need something to tell me what I was doing back then. I also have, like, sometimes in a while I put like a text file next to it. What the hell was I thinking, that text? Because when people ask me why I did it this way, usually it was because there was some limitation. So that's the first reason, for myself. I know I'll be reading it. The other one is, I think this is dreadful and I never want to do it again and I want somebody else to do it. So I write the documentation so somebody else can fix this for me. This both saves me a lot of time. For me, it boils down to the question, who's reading your documentation? Because if no one's reading the documentation, is there any other reason? No. Because what will happen if nobody reads the documentation? You will know nobody reads documentation. And what will happen? You will postpone it, or you will not spend time on it, or you will forget it. Because nobody likes doing stuff that nobody will use, because it makes you feel pointless. So, have a reason why writing documentation. And if somebody tells you just because I said so, say no. And this is another one where, you know, if they say what I'm saying so, let them email me, I'll tell them no. Because writing documentation for nobody is pointless. You can spend that time writing spec tests. Then a question that very often comes up, where to put the documentation. I've seen it in multiple places. I've seen it in Google Docs, I've seen it in wikis, I've seen HTML pages. I prefer the documentation as close to the source as possible. So what we do is we add a readme.md files to modules. We add stuff in comments above the actual classes and modules, and I like to use Markdown for it. And the main reason I'm using Markdown for it is because it's easy to convert. I can convert it to PDF files, I can convert it to HTML, I can make wiki code from it and upload it to a Confluence wiki by using the API. The biggest benefit you have is that when someday some manager comes in and says, we're now using this document solution, you have to use that, you just have to spend time writing the script to convert Markdown to the new environment, run the same script again, and go home early. And wouldn't we all like to go home early once in a while? So this is that slide with the important links, which is in small font because it's for later reference. And I'm done a bit early because I didn't need to do the roles and profiles in depth. But any questions?
What about defining the roles and profiles in Jira?
Oh, good question. Actually,
what is your opinion about that? What is your opinion about doing it that way?
This is a nice one, because that's what I'm currently doing at Sanoma. So my colleagues are looking at me now, this is what he's going to answer. It's both good and bad. In the beginning I thought it was totally like the worst thing ever. In practice it's not so bad. What we use it for now is that we have like the list of profiles as an array in Jira. That way if you specify a wrong profile, something which doesn't exist, at least it will fail and tell you like I can't find this specific profile. It gets bad when you need to implement files, because when we have, like for example, in Jira a few things where we want to create a file, and then you have like this whole blob of data in your Jira file. So there it becomes less tricky. It depends a bit. I think you have to find the balance between what can I put in Jira and define most of the stuff there. Though if you start looking at your Jira code and it starts resembling a Puppet manifest, so it says like files and then the whole file tree with all the settings comes out of it, I would highly recommend trying to convert that to a dedicated object, like a dedicated manifest. So one of the things I, for example, do is that I make like a profile Apache vhost manifest, specify the defaults for my company in there, and only make sure that people in Jira have to define what they need. So like the domain name, what ports it's running on, and the rest can be overridden for the exceptions. But most people can keep the Jira code short and readable. That's a bit my opinion. I could definitely talk about hours about how you could improve that or how you could look at it. It's not bad necessarily. Any others?
Anything else? Up on the first floor up there? You're allowed to ask questions too. We haven't had any from up there all day, because I'm going to make you shout it down, and you probably know that I'm not going to run up those stairs to where you are with this microphone. Okay, round of applause. Thank you so much.